Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 6.2.6. This is the last homework we're going to be looking at before we get into the study guide and check over the study guide before the chapter test that we're going to be soon taking. So the M&Ms for this is finally getting into the official notes for scale factor. And as you recall from our lessons, the scale factor is always a ratio of corresponding sides. And specifically, we typically call the scale factor that ratio from the new, where we have the new over the original. So it's always based on the original. As I've said many, many times, it can actually go in either direction. Okay, so if we know these two sides are corresponding sides, we can put those together to form a scale factor, but it doesn't really matter if the scale factor is 5/4 or if it's 4/5. It just depends on which direction you're going in. And so if we're trying to find this quantity right here, and we know the 8 is the length of this side, then we will multiply 8 times 5/4 because the new shape is bigger than the original. So we would want the scale factor that's greater than 1. However, if I know that this side right here is 12, and I'm trying to find this side is less than 12 because the original was smaller than the new one. And so in this case, we would take 12 and multiply it times 4/5, and that's going to give you the length of side X. So yes, you could use this formula and then choose whether you're going to multiply or divide by that scale factor, depending on the known information. But for me, it just works better to use both of them and just choose which one you're going to use and always multiply. It says sketch and label a pair of similar shapes, like this right here. Rewrite the expression so that the operation is multiplication. All right, so in this case, when you divide by 1/2, what they're implying here is that your scale factor is 1/2, and you're going in the opposite direction. And so instead of multiplying times 1/2, you would divide by 1/2. But I would just say, just multiply times the reciprocal, right? And here, same thing, multiply times the reciprocal, and that will give you the new side. Sketch the triangle below, then draw it with sides that are 1/3 as long as the sides of the original. Okay, so if you're going to take 1/3 of 9, it's going to be 3, 1/3 of 15 is going to be 5, and 1/3 of 12 is going to be 4. So these will be the dimensions of the scaled down or reduced triangle. Then it says calculate the perimeters. We'll just add each of these up. Notice how this perimeter, which is 12, is exactly 1/3 the original perimeter that was 36. But the areas, this is not 1/3 the area. This is 1/9 the area. So why is it different? Well, the reason is because when you have a scale factor, the scale factor only applies to the linear measurements. When you are working with area, those are square units. And so you would have to square the scale factor to find the number of times larger or smaller one shape is than the other where it pertains to the area, okay? When we get to volume, it'll be a cubic difference, right? It won't be squaring the scale factor, it'll be cubing the scale factor. In fact, why don't I just go ahead and show that right now? Let's take a shape. I'm going to take this shape right here, which is, we'll call this a cube. Boom, 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 boom. Oh, do I really want to make it this big? Maybe I don't. Hold on. I'm going to change that. I'm going to just make it a single cube. Okay, so if I were to triple each one of these lengths, this would become a 3x3, right? 3x3. And we're going to go to there. We're going to go to there. We'll go to there. We'll finish this process. Finish this. This is going to go there. This is going to go there. This is going to go there. And there. And there. And they're beautiful. Okay, so this particular side length right here was increased by 3. So the scale factor is going to be equal to 3 to the first power because we're talking about a linear measure, which is one-dimensional. The area of this side is 1 square unit. The area of this corresponding side is 9 square units. So the scale factor, which was 3 here, is now going to become 3 squared because this is 9 times as big the area as this one. And now let's look at the cubic measurement. This is 1 full cube, right? But after applying a scale factor of 3 to the linear measurement, this is 9, 18, 27 cubes. So the scale factor as it pertains to volume is going to be 3 to the third power. This has 27 times the number of cubes in it than the original one did. Okay, so scale factor when we're talking about scaling objects only applies to the linear measurements. The area measures and the volume measures are not the same scale factor. They're actually exponentially higher scale factors to the second degree and to the third degree. All right, more box plots. Wonderful. Says Lucy and Marissa each designed a box plot to represent this data. The plots are shown below. Which plot is scaled correctly and which one is incorrect? Okay, so one thing to be aware of, we've got them in order from least to greatest. You got a minimum here. You got a maximum here. 1, 2, 3, 4, 5, 6, 7, 8, 9, which means that the median is right there. And the first quartile's here, and the third quartile is right there. So what we do is we plot those 5 points, 16, 19, 25, 27, and 35 for our box plot, and our box plot has to reference a true number line, a scaled number line. This is the one that is referencing a number line that is properly scaled. This is not, I don't even know what that is. That's not a number line. It's just a line with a bunch of numbers underneath it. They're not properly scaled. There's no even tick marks to know what the scaling is all about. So this one is absolutely wrong. So to fix this, well, you do it like this one, basically. Do it like, I don't know whose is whose. Is that Lucy's? Or I guess it doesn't matter. This is the correct one. All right, draw a coordinate graph, then plot the following points on the graph. -3, 1, -1, 3, 4, 2, and 2, 0. So that was A, B, C, D. This is the original one that we were asked to draw. Then it says, what is this shape? Well, that's a parallelogram because the opposite sides are parallel to each other, right? Definitely a parallelogram. Then it says, reflect the shape across the x-axis. So here is the x-axis, so that serves as your mirror. This point is on the x-axis, so it's going to stay on it for the reflection. This takes 2 units to get there, 2 units to cross. 3 units to get there, 3 units to cross, 1 unit to get there, 1 unit to cross. So this is the mirror image of that original parallelogram A, B, C, D. Notice how I've got the 1. These are the images of the original. And since we're going to do it again, I'm going to call these the first image, and the other ones will be the second image. And so I think for this one, this looks as if it's a, it must be a dilation, right, where it's been enlarged. And I'm going to suggest that maybe the scale factor was 3 because this looks like it's 3 times as long as that. So let's go back and look at the directions. And sure enough, increase this, dilate it by a scale factor of 3. So each one of these points here, you multiply the x value times 3 and the y value times 3, and then you get your image for each one of those and plot those points. Examine the diagram at the right. The smaller triangle is similar to the larger one. So this is the larger triangle. This is the smaller triangle. They are similar to each other, right? You see that, how they're similar to each other? All right, so with that being the knowledge, we know that the side lengths that correspond to each other are going to be proportional. So the x will correspond to the 8, and the 8 here sometimes people make the mistake of saying the 8 corresponds to the 10, but the 8 actually corresponds to the total from here to here, which would be 18. So we can put the 8 and the x in the numerator and the 18 and the 8 in the denominator. And please make sure, since the 8 and the x correspond to each other, they both go in the numerator, and the 18 and the 8 correspond to each other, so they go together in the denominator. So to solve this, use proportional reasoning, and I believe doing your cross products is the easiest method, and then eventually we'll divide 64 by 18, and that's going to give you the value for x. Sequence of transformations. A figure is rotated and reflected. What can you say about the new figure in relation to the original? Well, we know that those are both rigid transformations, right? So that means that the new figure is going to be congruent to the original figure. Then it says a figure is translated, reflected, then dilated. What can you say about the new figure? Well, it's not going to be congruent because it was dilated. It's either bigger or smaller. So it's going to be the same shape, but it's not going to be the same size, which means it'll be similar, but not congruent to the original. All right, checkpoint problems. We just learned this earlier in the year, and now we're hoping that you have this mastered. Okay, so what are we doing here for each situation below? Complete the representation of patterns web by finding the missing table, graph, and/or rule. Since there are many possible patterns, it is not necessary to create the patterns for these situations. All right, so looks like for A, it looks like each one of these was growing by 2, and when you work backwards, you get a y-intercept of 2 as well. So y equals 2x plus 2 is the rule for this situation. This would be what the graph would look like, y-intercept of 2, and then it goes up 2 for every one it goes to the right, and then here's the table. For B, the rule says the y-intercept is at 7, and then the growth rate means it goes down 3, 1 to the right, down 3, 1 to the right, down 3, 1 to the right. And then the y-intercept is at 7, and it's going to decrease by 3 as x increases. This table, it looks as if the growth rate is 3, right? Because it goes from 1 to 10, which is an increase of 9 in 3 steps. We must be counting by 3s. The y-intercept is given, it's at 1. So for the graph, start at 1, and since the growth rate is 3, you go up 3, 1 to the right, up 3, 1 to the right, up 3, 1 to the right. And then for our last example, they give us the graph that has a y-intercept of 6, and it goes down 2 for every one it goes to the right. So negative 2 over 1, which we're just going to write as negative 2, because we don't need the 1 as the denominator. And then these are all ordered pairs that can be put into the graph. So 0, 6, 1, 4, 2, 2, and eventually 3, 0. And that concludes our homework for Chapter 6. So now we're going to go head over and work on a study guide, and I guess prepare for the chapter test, which should be coming within a day or two. All right, take care. Bye.
Hey, feeling good, like I should.